Now we're going to, in the remaining hour and a half or whatever, we take on one of these, one of the most problematic topics in school mathematics, rounding. Now, in this case, by the way, at the beginning, it will still be whole numbers. And you have taught, and therefore you must know. I think even in high school, you have to teach rounding, no? Yeah. No? Yeah. Most of the time, it's about whole numbers. Most of the time. And you make excursions into decimals, but that's more rare. So basically whole numbers. Even with decimals, it's okay. But as we go into the explanations, we'll have to bring in fractions. Now, we have not done fractions. Fractions is tomorrow, right? So what am I doing? Well, it's because the topic itself already comes in third grade, second grade even nowadays in some textbooks. And you cannot avoid it. So you have to wait till you have fractions before we discuss it. Yeah, that's okay, except that you sort of miss the boat because it comes in the discussion of whole numbers, and why do you wait? You know, you lose the context. So I rather err the other way, which is we discuss rounding, whole numbers, some limit of decimals maybe. We can do it. We can do without it. And so to make you understand the basic problem here, right from the start. And when the explanation comes and I invoke some percents, invoke some fractions, well, if you feel uncomfortable about it, well, just wait till you're done with fractions next week, and you come back and visit it. It's in chapter 11 or whatever. I think it's 11, isn't it? No, 10. Yeah. Then you can read that again. So it's just inevitable that when you talk about whole numbers, you have to talk about that estimation. Now, I want you to realize the sorry state of this topic. So earlier there was a question about why they allow inverse, right? Inverse operation, that kind of language to persist in the textbooks. Well, never mind that. Look at what's happening. Let me look at the field. I mean, I don't want to spend too much time. Maybe at the end we can come back and see what we can do to correct the mistakes. Now, this, I just quickly go through it. Here they say, round numbers. That's the title, round numbers. This section is about round numbers. Okay, there we go. See, round numbers. Right? That's the title of this section. And you can see, it just only talks about the scale of rounding. You see, there's absolutely no explanation of any kind. Look at the bottom left. To round a number, find the place to which you want to round. Look at the digits so it's right. If the digits are less than 5, the digit in the rounding stays the same. If the digit is 5 or more, the digit in the rounding place increases by 1. So that's just skill. On the other side is just exercises, nothing. Okay. Now I want to show you several, so give you a fairly comprehensive picture of. So this is about add and subtract 4-digit numbers, and to show they have conceptual understanding, they talk about estimation. So see that near the top, here's a find the sum 9910 minus 7340. See that? The next line says estimate. It just says estimate. Doesn't say how. Just say so. I guess you understand that they're rounding to what? To the nearest thousand. Nearest thousand, right? Do you think that's really good? That's the issue. We'll come back, right? So then they say, well, round to nearest 100. So 10,000 plus, actually it's not minus, sorry, I didn't read it. 7,000 is 17,000. And down there, it says combined area, if you do precise computation, is 17250, right? But the estimate is 17,000. Therefore, it looks reasonable. Now, how do you know that's reasonable? You missed by $250. You want to lose $250? You want to give me $250 if $250 is reasonable? You want to give me $250?
Shouldn't it say 17,000 is reasonable anyway?
What?
The estimate 17,000 is reasonable, so it's already been printed down.
Uh,
Well, 1750.
no. The fact that the answer is close to the estimate
I know
is reasonable.
17,250 isn't reasonably precise.
No, the estimate is 17,000.
Yes.
Yeah.
The real answer is 17,250. And they say, well, it's close to the estimate, right?
Oh, that's true.
Right? Therefore, the answer must be correct, or at least it seems correct.
Well, you know, you added instead of subtracting for the operator.
Yeah, I think what they're trying
That's
to
what
say is
that's what they're trying to get at.
since you estimated it.
Well, I mean, I don't think that's the issue. Whatever operation you use, they're with exactly the same kind of problem. In other words, in general, why do you round to the nearest? Why not round to the nearest 100? So why not?
Why are they finding the difference?
A textbook like this, is it trying to teach or is it trying to say something about?
Maybe because they just wanted to go to the easy math back with 10 plus 7 instead of
If they want to do that, they should explain why they want to
99
do
plus
it.
73.
Because this is supposed to educate students, not to show off whatever skill you have. The purpose of a book is always to educate. Right? You do something like this, that means you do something at random. You don't care whether students follow you or not. You just say, this is what I've done, it's reasonable. Next question. Right? Now I just want to give you some total impression. So let's go to another one. Again, the topic is, again, estimate products. You see, so you said when it's subtraction, now it's multiplication. It's the same thing. So you see it? Oh, sorry, let's see. Okay. I don't know if that's getting better, but. So you see, again, the same thing. You have to multiply 289 by 4. You get it from the top? So you say you have to estimate, in the middle, estimate 4 times 289. Step 1, round 289 to the nearest 100. Then you estimate. Then the estimate is 4 times 300. Therefore, the estimated end product is 1,200. And then you get, oh, well, that's that. Okay, that's that. Sorry, that's what they have to offer.
This is just about estimation, not doing it.
Well, that's what they do. That's I can show you. Huh?
4 times 3 is 12. 4 times 300 is 1,200.
Yeah.
And it says 1 0 plus 2 zeros is approximately
2 zeros.
Or is that equal?
Equal. It's
It's
equal.
0, 0 plus 2.
I don't know what that means. Look, I'm not going to explain this. Now, the next one. The next one is explicit. It says multiply 4-digit numbers, okay? Now, the highlight is mine. Sorry, I was inspired, so I highlighted it. So look at this. You are supposed to multiply 1276 by 3, right? And they say you estimate. Now, this time, all of a sudden, they round off not to the nearest 1,000. Look at it. 100. How do you think a student is going to react? And so the highlighted thing, can you read? Yeah, it says 3828 surveys were sent. Since 3828 is close to the estimate of 3,900, it is reasonable. Who says what is close, what is not close?
Right.
Who says?
Yeah.
Which one's reasonable, the estimate or the? Yeah, I don't think the last one said the answer.
So, well, I don't think I need to show you the last one, more of the same. I mean, so This is the worst part of the school curriculum because it's almost as if some other thing there might be one or two redeeming features, but in this, basically, anything I've seen is just totally unacceptable, like this. It's treated as a random topic. They can do whichever they want, and you're supposed to follow. So yes, yeah, Marie?
In our textbook, which is not this one, there is a series of lessons on the correct, what they not exactly sure, it's about the power to estimate and why you would use the smallest place value possible to round. They talk about the difference between rounding the hundreds and rounding the tens, and why you want an answer that's closest to your real answer, and to make it still. So the issue is
This-
part of envision. The envision.
Envision. What grade?
I believe that I can't remember whether it's fourth or fifth. I teach both, so it's hard for me to remember.
Okay, so next time when I look at that series,
It's fourth, actually.
I'll try to be kinder. Now, this is something that really, well, except for that one thing that you mentioned, which I have not seen, but I trust you that maybe once in a while they actually know, like broken clock tells good time twice a day, and they get it. Okay.